Greetings and welcome to my new calculus channel. My name is John Gabriel. So in this very short video I'm going to explain to you something about the new calculus and inflection points. So in the new calculus you do not have derivatives at inflection points as you do perhaps in mainstream calculus, because in the new calculus you have consistency. That is, if you have a tangent line, that means there is a derivative. And if there's a derivative, that means a tangent line. Now in the mainstream, that is not the case. For example, you can have a tangent line and a derivative, and a tangent line and no derivative. So somebody here made a comment, somebody called Jakub Winiak, or Winiak, I don't know how to pronounce that. And he was asking what is the difference between calculating a derivative for the cubic at x is equal to 0 in mainstream and new calculus. So in the new calculus there isn't actually a tangent line at x equals 0, because tangent line is defined in the classical original way in the new calculus. In other words, it meets a curve in a single point, extends to both sides, and crosses it nowhere. Okay? So let's look at a quick example. So this is the cubic. So if you look at the cubic, the auxiliary equation for the cubic will be this red highlighted text. So you'd find both the derivative and the difference, which is always 0 in the new calculus, by the way, unlike the mainstream calculus, where this is only 0 if f is a linear function. And of course, my historic geometric theorem was realized from the new calculus, this expression here. So now, we simply take the original function and we go through the process of dividing it by n plus n, and we end up with this expression here. We know automatically that the terms in x are the derivative, which is 3x squared, and that the red font is the auxiliary equation. And of course, we can form two equations to find m or n depending on the other. Now in this scenario here, we're always given x, and we can choose either n or m to find the other, right? So getting rid of this, here is the curve. Now if you try to come to the point 0 here, there's not going to be a derivative, and it doesn't really matter in calculus, because the mean value theorem doesn't care about inflection points. That means you'll get the same area. And by the way, the mean value theorem is the fundamental theorem of calculus. If you don't understand that, I'll put a link in the details section. You can look it up and see how you can derive the so-called fundamental theorem from the mean value theorem in one step. So that's all I really wanted to point out. This process is quite interesting, because in the new calculus you can do a lot of things with the auxiliary equation. And there are a lot of other videos out there which I've already done, so I'm not going to talk about it again. Moreover, there are many theorems in the new calculus that will not be possible using the flawed mainstream definitions. For example, the Gabriel polynomial is always closed form. That means it has a fixed number of terms, which can vary according to the number of derivatives that can be taken. So it's a very interesting theorem, and it uses the new calculus derivative, meaning that you cannot use it in any other way unless you use new calculus definitions. So if you have any other questions, put them in the comment section. By the way, I do not address questions, I do not publish questions which are not civil, and which I've addressed in the past, and don't have time to deal with the drivel of anybody who has different views. I know I'm right, you're wrong if you disagree with me, and that's basically all I have to say. So that's it for now. Take care. Goodbye.